Hey folks, this is like if you're around like for the earlier talk, this is like very much in the same theme. I want to talk today about like KernelBot, which is a competitive platform for writing like fast GPU code. And this was like a sort of very much like an open source collaboration that I worked on with like a whole bunch of people. Like Alex was in the room, like Matei who's here. I won't make you wave your hand again. Eric, like Elaine, and myself. So yes, okay. See, they all waved, Matei. It's not a big deal. You can wave. All right. So the sort of like core motivation behind building a competitive GPU programming platform was that we noticed like there was hardly any interesting kernel data on GitHub. The data that's interesting is either uh, under a license where you can't train a model with it, or if it does have a permissive license, then it's like slop. And so we basically had been interested in like taking we had some early work, for example, with this project called Kernel LLM, where what we did was we used like compiler generated data to train an LLM. This works really well, but then the data looks like it was compiler generated. It doesn't look like a human actually wrote it. So again, how can we like flood the internet with like more high quality GPU kernels and get like LLMs to be like a bit better at solving this problem? All right. So basically here, like the sort of benefit we had with GPU mode is like GPU mode is a fairly active Discord community with like over 20,000 people at this point. People nerd out on all sorts of topics related to GPU programming, from like weekly lectures, like working groups. And so what we wanted to do was like we wanted to convince like more of these smart people on the server to donate to us like data for free. And the way, like the right way to do this is like we give them like money with prize pools and they give us their expertise back. So it's like a nice it's a nice and even exchange. All right. So the problem now is like, okay, well, we have 20,000 people. How do we give them all a GPU? That's very expensive. Even H100s are cheap. They're $1.90 an hour, but we can't give 20,000 GPUs to people. So we wanted something that's like a time shared. Like basically, we have like this one pool of GPUs, and then whenever you submit a job, you get access to a GPU. You run your kernel, and you get results back. The problem with most traditional setups for this is that like it takes a long time to queue a job, like on the order of 2 minutes to 3 minutes for like most serverless startups. And so our solution was like to have a workflow that takes closer to like 15 seconds or so, where you don't even have access to the hardware, but you submit like your code. Like in this case, you would attach a file within Discord directly, and you get like a result back like within 15 seconds. So we want it to be like fast and interactive in the same way that like good video games are developed. All right. So like I said, we had this like existing community that we could use. It was like fun. Like for instance, there was like an earlier question from Georgie on thermal throttling. Well, what one person figured out was they could like basically submit a kernel at the right time of day or depending on load and use that to get a slightly different kernel. So this is great. Like we love the creativity. And yeah, and although like Discord was quite nice in the beginning because we had this large community, like it is a bit clunky because every time you want to submit a new kernel, you have to attach another file and refill a bunch of like arguments, like which leaderboard was this, which GPU was this. And so this was like all quite clunky. So what Matei built was like something really neat. It's basically a CLI where you can just say like popcorn CLI submit with your file, and then you can just submit a kernel. So like at the top half of your monitor, you'll have VS Code, and the bottom half, you'll have your terminal. We use Rust. It doesn't matter because I don't think Rust is the bottleneck here, but like Rust is cool. The main problem is like there's like less community interaction here, but it is eventually what like most of our advanced users ended up picking up. We also have like a very nice website that like Elaine here in the audience like built for us. So it's like very similar. You can come, you can see the leaderboard, you can see who's like a very top entry, and similarly you can click on a specific problem and then like submit stuff like directly like within the website. So this is like over the long term what we expect to be the primary experience people to have on the server. So all of these make it nice. Like people can just use whatever they want, and we're quite fortunate that a lot of our smartest hackers would make write-ups describing how good their solutions are. So we have an architecture diagram, but like, it's a bit boring. Let's skip it. All right. So the sort of quick things we learned here is that like designing hard, interesting problems is tricky. Like you want a problem that's interesting. You have to pick like meaningful problems and shapes as well. You can't just like pick very small ones because then you just like measure overhead. We also noticed that like sometimes the data distribution could be gamed. For example, if you wanted to produce the world's fastest vector mean kernel and you're doing like random inputs with mean 0, well, the result is almost always 0. And so that's the world's fastest vector mean kernel. That's bad. So we want like basically our problem distributions to avoid these kinds of problems. So we have like a whole bunch of tests. Of course, the trade-off here is that this increases the time and it wrecks the interactability a bit. The other thing was like security. Like we're basically distributing like very valuable assets to the rest of the world. And people can submit Python files, and like Python is an interesting language. Like for instance, in Python, you can within a Python file pip install stuff, and it like works. You can like start an SSH server, you can start a server that also works. So we had to do a lot of work to avoid hacky submissions. Like one source of hacky submissions is also people figuring out how to game our eval suite. But like this is the kind of thing where we like to see because we like patch the eval, and for now, most of our community has been very nice about like escalating like sort of these tricky issues to us. All right. There were some issues though, like for instance, one of the earliest design decisions I made turned out to be one of the most questionable ones, which is that we use GitHub Actions as a scheduling mechanism. So basically, hardware vendors will give us compute, we'll hook it up as a GitHub runner, and then you can like basically, we have the artifacts stored on the GitHub action. And so this is like, we're basically using it as a replacement for Kubernetes or Slurm. It's okay, like it works, but it's not my proudest design choice. The other problem is that like but the reason why we need to use this and we can't purely rely on serverless stuff is the vast majority of neoclouds don't enable NCU access to them, so you can't like get access to like a real profiler. Although you can, it's like a flag that's like this flag, and you can enable it. It's not by default because allegedly NVIDIA's security model doesn't make this easy. But like I said, like I think this should be a default. If any person here that works at a neocloud and you'd like me to tweet about you, please enable NCU access, and I'll give you a free advertisement. And I mean it. All right. The other thing was like this cold start time, right? I talked about how we wanted things to be interactive, and just queuing a simple job on GitHub Actions takes about like a minute and a half because you need to spin up a container, install PyTorch with CUDA, run the job. This takes forever. And our budget was closer to like 15 seconds. A lot of this is solved by using modal, where we tend to see these like sub 10-second times. The other thing is like for people that are using native code, well, turns out if you're using load inline and PyTorch, load inline by default will like read about 7,000 like C++ files before like it can actually like bind a kernel. This is very bad, and like the overhead here, it doesn't matter how fast your machine is, like that has high overhead. So we just don't do that, and now the compile times go from 90 seconds to 5 seconds. The other thing we're quite excited about has been like leveraging NVRTC a bit more. So NVRTC is like a very fast, slightly more restrictive library compiler that you can use. But it's like makes compile times here go to like 0.1 seconds, and it's like 0.01 seconds. It's like absolutely fantastic, and more people should know about and use NVRTC. So yeah, I mean, how do we convince people to participate though? Well, a big part of it is we want to partner with companies to optimize their problems. So we've had two different 100K kernel competitions that we've worked on with AMD. So this ranged from like first like doing DeepSeek inspired kernels to like now doing more like comps kernels. And we're also really thrilled. Like we're going to be launching another competition with NVIDIA starting roughly this Friday, I believe, if everything goes well. But that's going to be like more focused on like gem and low-bit kernels. So if you're interested in technologies like QDSL and Qtile and a lot of like that fun stuff, you should check that out as well. All right. So the main way we design a competition is that there's like we assume basically a PyTorch reference, like as in PyTorch determines like what is correct. We pick a bunch of relevant input shapes by looking at real models. We have some sort of ranking formula, like is it like the mean or the geomean, and which problems might have different scores. You give some prize money, and great. And this is like much cheaper than hiring a grumpy CUDA hacker for $1 million a year. So like I think more companies should do this. Right. So we've done like a bunch of smaller competitions. Like for example, Alex, who isn't here, like designed this like kind of nasty problem called trimul, where you have like two matmuls with like with a nonlinearity and then another matmul. A lot of compilers fall flat on their face here. But like with David Barrar, who's like now unfortunately at Anthropic, like also figured out like a very clever solution for this by like changing like memory layouts in a Trident kernel. So yeah, I mean, yeah, I guess I was trying to vague post here, but like I said, we have another NVIDIA competition coming soon. So I hope you'll enjoy that, and I think we'll make it very interesting. So yeah, I mean, the outcome now is that like we have a community of people that are interested in GPU programming that want like well-scoped problems. It went fairly viral at this point. We've aggregated over like 60,000 like high-quality kernels from about like 600 users. And by default, we make it so that all the kernels that are submitted are open source. So basically, just by submitting it, it's not ours, it's yours. You can train a model, you can study the kernels, you can do whatever you want. Like life is good. Right, so yeah, I mean, if you're interested, getting started is as simple as this. You can install the Popcorn CLI with this, like, sorry for installing a shell command from the internet, but this is what we do these days. And then you can like register, authenticate via either GitHub or Discord. And then when you want to make a submission, you just pick a problem, you pick a GPU, and you should try doing well on the grayscale problem. That's like one of our most popular like beginner problems. So yeah, if you're interested in learning more, just check out gpumode.com. You'll see all the instructions for it, and I'd love to take questions. Thank you. I'm surprised Georgie doesn't have a hard question for me. So, okay, you asked all of them. Okay, sorry.
Could you talk a bit more about the AMD like backend platform and like how did you manage that? Because like for like NVIDIA, there's model and you can probably do much faster like instantiation with that. But with AMD, in my experience with the competition, sometimes it took like 5 to 10 minutes to just get a GPU. So how did you manage that? Was there a cluster that you got or something like that?
Yeah, it's a great question. You're right. Like, so Modal doesn't support like AMD. So the way we made this work is this is why like GitHub Actions work. We basically tell cloud vendors with bare metal access, please run the script. It'll connect the infrastructure to us. And then we can basically queue GitHub action jobs to it, and like things just work. It is a bit clunky because you have to maintain the machines. They might hang, some dependency might happen. But like barring a good serverless solution, I think we've settled on a fairly good design.
I guess with these neoclouds, are you renting these out sort of sporadically, like on demand, or do you have like some clusters already like reserved? It's okay.
Yeah, so I'll just repeat the question. So the question is like basically, well, what's our collaboration like with neoclouds? Do we rent it? Do they give us the compute? Yeah, so generally, like I would love it if we could just like host our own compute, but like it's a bit tricky to host some of this bigger compute like in something like an apartment. So you do actually need a professional to house it. And so for neoclouds, like I think for a lot of them, they want to engage more with GPU hackers. And so like as long as we give them like good enough publicity and as like they get like enough users to their platform, they effectively just like compass the compute. And so for context, like all of the hardware costs for GPU mode, I've paid for out of pocket, and it's cost me like around like $80 or so to manage like the entire service over the last year. So I'm pretty proud of that. So, and a lot of the work from people here as well.